Hello and welcome back to Morse's Math Morsels. And here is a problem in polydivisibility. Wow, polydivisible. What does that mean? Well, from another video, it means that the number formed by the first n digits is divisible by n. For example, 123 is polydivisible. 1 is divisible by itself. 12 is divisible by 2. And the whole number, 123, is divisible by 3. But not 1, 2, 3, 4, because that's not divisible by 4. So we need to put in a 4-digit number divisible by 4. For example, 6 would work. That's divisible by 4. And for a 5-digit number, you can only have a 5 or 0 at the end of a 5-digit number for divisibility by 5. So this problem asks, find the least whole number n such that 10 million times n is polydivisible. And since we have a whole number and n is going to take the place of that question mark, the whole number is going to be at least 8 digits long. And hence, it will have to be a multiple of 7 and 6, 5, 4, 3, etc. all the way up to 8. So if we try different digits, like any of these 1 through 9, none of them will work. We can't put 1 or 2 in there because 100 or 200 are not multiples of 3. We can't use 30 million. 30 is divisible by 2, 300 is divisible by 3, 3000 is divisible by 4, but we run into the 7-digit number 3 million, which is not divisible by 7, alas. And for that reason, we cannot use 4 or 5 either, because they're not multiples of 7 either. So it looks like n has to be at least 2 digits. And if n is 2 digits, this whole number will now have 9 digits. Therefore, it will have to be a multiple of 9 in addition to 8, 7, 6, and so forth, all the way back to 1. So in order to have a multiple of 9, the sum of the digits of n must equal 9. Or multiple of 9. In order to be divisible by 9. So our rules from number theory. And this has to be a multiple of 7 as well, because we're going to have a 7th digit, one of those zeros included. As for multiples of 5, they're taken care of because there's going to be a 0 along this number that will be in the 5th position, so polydivisibility by 5 is taken care of. And as for 8, and 2 and 4, well, an 8-digit number ending in 3 zeros will always be a multiple of 8, because 1000 is a multiple of 8, and so all the multiples of 1000, which all end with 3 zeros, are hence themselves multiples of 8. So we need to mostly concentrate on multiples of 9 and 7. What's the least multiple of 9 and 7 that we can try out? Well, I'm going to write down try n equals 63, which is just 7 times 9. Well, place the question marks, put in try 630 million. Is that divisible by 1? Yes, all whole numbers are, except 0. 0 divided by 1 is 0, but we're ignoring 0. How about 63? Is that divisible by 2? Nope, that leaves a remainder. Alas, two-digit number cannot have an odd digit in the ones place. It's not a multiple of 2. So let's try the next greater multiple of 63. Try n equals 63 times 2, 126. Will that work? Oh, we're up to 3 digits. Now we have 1,260,000,000 instead of 63 million, so we have a 10-digit polydivisible number. But is it really? Let's see. 1 is divisible by 1, good. 12 is divisible by 2, good. 126 is divisible by 3, so far so good. 1,260 divisible by 4, and this by 5, 12600, 5. 126,000 first 6 digits divisible by 6. Is it? Yes. 1,260,000 divisible by 7. Yes, we chose multiples of 63, so everybody knows multiple of 7. How about divisible by 8? Are those last 3 digits zeros? Yes. This is a multiple of 8. Oh, how about multiple of 9? Add up all the digits. 1 plus 2 plus 6 is 9. Add all the zeros, we're still at 9. Yes, it is a multiple of 9. And finally, the 10th digit, the 0, is this whole number a multiple of 10? Yes, it ends in 0. So it looks like we have found the answer to the problem of the polydivisible number n, such that n times 10 million is in fact polydivisible. N equals 126. That's our final answer. Thanks for viewing.